All right, I want to start off with some of the basics of trigonometry, and that's going to be the basic trig functions as well as their reciprocal functions. Before we get into that, what's trig? Well, trigonometry is going to be the study of the relationships among the sides and angles of right triangles. Trigonometry is all about triangles, the angles inside of them, as well as how their sides are going to be related to those angles. The trig ratios are the comparison of the side lengths of the right triangles. I'm going to show you those basic trig ratios in the same way that Mr. Greeno showed me a million years ago. To get into that, we need to first look at a right triangle, and here I have one. Remember, trigonometry is studying that relationship between an angle and the sides. And so we need an angle as a reference, and I have an angle, an interior angle to the triangle right here. That's theta. The three sides of the right triangle depend on this angle. The hypotenuse is always the hypotenuse. That's the longest side of the triangle. But we need to recognize that on the opposite side of the triangle, that's the opposite side. And the side that is right next to that angle, that makes up one side of that angle, is called the adjacent side, because adjacent just means right next to. Now, there are three basic trig ratios, and how we keep them straight in our head is with this word that you've seen at the top of the screen, SOHCAHTOA. That's what's going to help remind us about the three trig functions. The first one we have is sine, and we abbreviate sine S-I-N. And so this is read the sine of theta. And its trig ratio is going to be a ratio, so comparison of two numbers, where the sine of theta is going to be the length of the opposite side over the length of the hypotenuse. That's what SO means. Sine is opposite over hypotenuse. The next trig function is the cosine function, and it's abbreviated as cosine theta, COS. So for ca is for the cosine, and cosine is the ratio of the adjacent side to the hypotenuse. Then the third trig ratio is the tangent, abbreviated tan, T-A-N. This is read tangent of theta, and if you're following the pattern for SOHCAHTOA, tangent is going to be the ratio of the length of the opposite side to the length of the adjacent side. So remembering SOHCAHTOA is going to be something that helps keep everything straight for us. There are three more trig functions. These are called the reciprocal functions: secant, cosecant, and cotangent. They're all related to the first three, sine, cosine, and tangent, as being reciprocals. Let's start with the easiest one. Cotangent is obviously going to be the reciprocal of tangent. But when it comes to secant and cosecant, it's easy to get these ones confused. The reciprocal of secant, or secant, is the reciprocal of cosine. And cosecant then is going to be the reciprocal of sine. How I keep this straight is that I recognize that between each pair, we only get one co. That's what I tell myself. What I mean by that is, for cotangent, it's paired with tangent. There's only one co in there. Secant doesn't have a co in it, and its reciprocal is of cosine. For cosecant, it has the co, so it's paired with sine, already having one co in it. So I don't know if that'll be helpful for you, but it's definitely helpful for me. The only thing that I really want you to be able to do with this video is to be able to identify the 6 trig values. So if we're looking at this 3, 4, 5 triangle, and in reference to this angle alpha, we want to find sine, cosine, and tangent first. We think about SOHCAHTOA. Sine being the SO. So for sine of alpha, we have to recognize the opposite side is 4, the adjacent side is 3, and of course 5 is always the hypotenuse. So the sine is going to be opposite over hypotenuse, 4/5. Cosine, the ca is adjacent over hypotenuse, so adjacent is 3 and the hypotenuse is 5. And for tangent, we remember TOA. Tangent is opposite over adjacent, so opposite is 4, adjacent is 3. Then when it comes to the reciprocal functions, we just take the reciprocal of these fractions. Cotangent is reciprocal of tangent, so its value is 3/4. Secant is a reciprocal of cosine, so 5/3. And cosecant is a reciprocal of sine, so the value of cosecant of alpha is 5/4. If you're asked to find the 6 trig values for angle A in triangle ABC, when AC is 15, BC is 8, and AB is 17, a good first step is to draw a triangle. So I've drawn a triangle here, probably not to scale, but in my triangle I definitely have a right angle right here. And there's definitely a smallest side and a biggest side and a middle side. That's important because we have these 3 different lengths over here and I need to know where to put them. So the smallest side is 8, the longest side is 17, and the middle side is 15. We also need to be able to identify what those angles are going to be. AC is the 15, so that means that it's either AC or it's AC. So which way does it go? If we think about the side that has length 8, that's BC, so that must mean that C is what's got to be on the corner here. B being on top then. So let me erase these. Don't need that one or that one. Once we have our picture of the triangle all set up, finding the 6 trig values shouldn't be too terrible. Remember that we want to find the 6 trig values for A, so we need to take a look at angle A right here. So 8 is the opposite side, 15 is the adjacent side, and 17 will be the hypotenuse. So to find the 6 trig values, we're going to start with sine, cosine, and tangent. You have to write sine of A. If you just write sine and try to say that sine is opposite over hypotenuse, 8 over 17, that looks incomplete. All right? It looks kind of silly. So you want to make sure that you have to identify which angle we're talking about, because if we were talking about angle B, its opposite side would be the 15 instead of the 8. So we have to say sine of A is 8 over 17. For cosine, cosine of A is adjacent over hypotenuse, so 15 over 17. And the tangent of A is opposite over adjacent, so 8 over 15. Once we have those 3, finding the last 3 are just, they're the reciprocal functions. So we go through cotangent, pairs up with tangent, so the reciprocal is going to be 15 over 8. Cosine already has a co in it, so its reciprocal function must be secant. And the secant of A is going to be the reciprocal of that, so 17 over 15. And the last one is cosecant. Cosecant of A is going to be the reciprocal of sine, so 17 over 8. This last one seems a little trickier on the surface. If we're talking about the sine of beta is 5/8, find the other 5 trig values. Well, how am I going to move around this is going to be fairly difficult if we don't have a picture. So the very first thing you should do is draw a right triangle. Trig is all about right triangles, so I've drawn a right triangle. Here's my right angle. And we're looking at the sine of beta. So we need to identify one of these as being beta. And don't use the right angle, just any other one is fine. And so I'm going to call this angle beta. we know that sine is opposite over hypotenuse, so the opposite side has to be 5, and the hypotenuse has to be 8. In order to complete the triangle here, we need to know what that third side is. And one thing we haven't brought up yet, but a thing that's super important to trigonometry, is what you learned in geometry, the Pythagorean theorem. That if I have this third side, we have a right triangle, and the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So a squared plus b squared equals c squared. When we want to solve this, x squared is going to be 64 minus 25, which is, what, 39? So we take the square root of both sides, and x is going to be the square root of 39. So back in my triangle, I'm going to take this x out and instead put in square root of 39. Now we have the entire triangle that we can start dealing with. And when we want to find all of the trig functions, I already know what sine is. Sine is what was given, is 5/8. But when we want to find cosine, cosine is adjacent over hypotenuse, so square root of 39 over 8. And tangent is opposite over adjacent, so 5 over the square root of 39. And we saw from before that when we simplify a fraction, we should get that root out of the denominator, so we multiply numerator and denominator by square root of 39, and that will simplify to 5 square root of 39 over 39. Now for the other three, that would be cotangent first. Cotangent of beta is the reciprocal of tangent. So instead of using that final simplified answer, I'm going to go back to that 5 over square root 39, because when I take the reciprocal of it, it will be square root 39 over 5. For the secant of beta, we have to take the reciprocal of 8, or of root 39 over 8, which would be 8 over the square root of 39. So simplifying that, it should be 8 root 39 over 39. And cosecant is the reciprocal of 5/8 or 8/5.